This is our second video in a series of 5 about the MacroSim economic simulation models. In the first, we looked at the structure of MacroSim 1, and we talked a bit about the derivation of the multiplier because that's important in that model. In this video, we're going to apply MacroSim 1 to ask some questions. So let's start that. Now here's some of the questions we can ask, and we're going to ask all of these. Does the multiplier work as we predicted in the model? Remember, the multiplier in the first video was 2.5, and that implied that if we increase investment by 10, that GDP should grow by 25. Can we confirm that it works that way? But related to this, if GDP grows by 25 and investment only grows by 10, where do the other 15 come from? Because it has to come from somewhere. We have the accounting identity at the top, right? Y is equal to C plus I plus G. And if I goes up by 10 and GDP goes up by 25, then where's the other 15? Explain. We, of course, have an answer for that. Also related to 1, if GDP rises by 25, will the budget deficit fall? What will happen to the budget deficit more generally? And question 4, if we increase government spending by 10, will that also increase Y by 25? So the two questions being asked here, the first 4, is what happens to, or the first 3 I should say, is what happens when we have an increase in autonomous investment. Then 4 and 5 are what happens if there's an increase in government spending instead of that. And so 5 is related to 4. If we increase government spending by 10, what happens to the budget deficit then? 6, if we cut the tax rate instead of increasing government spending, what will be the effect upon national income? Because it is a popular policy. And related to 5, if we cut the tax rate from 0.2 to 0.18, will tax collections increase? They might, because even though the tax rate is lower, the level of disposable income is probably going to be higher, so it's possible there's an elasticity effect there where tax collections would actually rise, given our assumptions. And the question 8, related to all of this, will the budget deficit rise or fall? That's tied very strongly to 5 and 6. And finally, if we do a whole bunch of things, like if we increase government spending by 20, what will happen if we increase the tax rate to keep the deficit from rising? What happens to GDP in a balanced budget policy? That's where, for example, if we increase the government spending, if we find there's a deficit, we say, well, we have to increase the tax rate to pay for that. How does that work? So let's take a look at this. Okay, on this slide, we're going to provide answers to question 1s, 2, and 3. Questions 1, 2, and 3. Does the multiplier work as we predict? If we increase investment by 10, will GDP grow by 25? If GDP grows by 25 but investment only grows by 10, where's the other 15 come from? And then finally, if GDP rises by 25, what happens to the budget deficit? Well, let's first start with our default assumptions, and that's all we're looking at here. That's why it says default. The little dark inset is the actual program or the segment of the program that shows the assumptions. And the printout from the screen, of course, shows the same defaults that we were using in the first video about MacroSim 1. So we run the default and we make sure everything's set up as we want it to be. And then, of course, we run a simulation that overrides everything. So in what sense are we doing that? Well, it's pretty obvious that here we increased investment from 420 right here to 430. So that's the stimulus we asked about in question 1. Now we can see that it did increase, the multiplier is being shown here as 2.5. It increased by 25. Because as expected, because GDP increased from 2,800 to 2,825. And we can see that, of course, part of that is investment. We increase that right here. But the other 15 is found in, for example, consumption. Consumption was 1780 on the default. Consumption has risen to 1795. And that's why the multiplier works, because there's a spread effect. It implies that if you spend an autonomous amount of money in building a new factory or something like that, especially in a region, but this is a national model, then it generates income, and that causes consumption to rise as well. And that is what explains, in fact, in this elementary model, the other $15. So taxes collected, though, also rises by a little bit, 560 to 565, and interestingly, the budget deficit actually falls. And so this tends to demonstrate that there's a relatively painless effect on the budget deficit if we increase investment by 10. It has a strong impact upon the economy. So questions 1, 2, and 3 are providing the answers that we are expecting them to. Now let's go take a look at questions 4 and 5. So we're saying here, if we increase government spending by 10, this is government spending rather than investment, will that also increase national income by 25? And related to that, if we increase government spending by 10 rather than investment, so this is a different kind of autonomous spending, this is policy autonomous spending, what happens to the budget deficit? So we make sure we roll our program back to the default again, and that's the standard default we've been using all along. And then we run the override, and we start by saying, look, here's government spending at 600. We increase that to 610 as predicted. The multiplier is still going to be the same here. This does have the same effect upon GDP. We went from 2,800 to 2,825 as predicted. It also has the same effect upon consumption. That explains the other increase by 15. Disposable income is up some. Disposable income, in fact, is up 20. And so that looks like that's very positive. But tax collections, even though they're up as before, we still are now running a larger budget deficit because, of course, this was financed by an increase in spending. The budget deficit has grown from 40 to 45. So this has increased the budget deficit. But it has not increased the budget deficit by as much as the spending increase. It increased the budget deficit by only half as much as the spending increase because it raised disposable income and raised consumption and raised tax collections. So the tax collections did not completely override the increase in government spending. We still have a larger budget deficit, but we have a smaller one that we might have had there not been this multiplier effect. So the answer to question 4 is yes, and the budget deficit increases. So let's go on to the next set of questions. So far the model is performing as predicted. Now this would make more sense to you, I think, and be easier to learn if you actually run these simulations yourself, which if you already know Python, it's trivial to download the model and to load in these overrides and see how the model is working. So I encourage you to do that. I'm just not requiring you to do that in this class because some of you don't know Python. Okay, questions 6, 7, and 8. If we cut the tax rate from 0.2 to 0.18, how will that affect GDP? And related to the previous question, if we cut the tax rate, will tax collections increase? We suggested they might, because this again will have a stimulating effect probably upon disposable income. It will raise taxes, therefore, or tax receipts, I should say, and that may offset the effect of the tax cut. We'll see if it does. And then what happens to the budget deficit if we cut taxes. So again, as always, we're looking here at our default. As we've always started with, so we go back to 0, and then we run the simulation, and let's take a look at what we've got here now. Now here you can see we cut the tax rate, as we said. Here's the original tax rate at 0.2. Here's the new tax rate at 0.18. This does have a strong stimulating effect upon GDP, stronger than the government stimulation, to be sure. stronger than autonomous spending. The multiplier has changed, by the way. It's grown larger, but that shouldn't be a surprise because the formula says the multiplier is dependent upon two things, upon the consumption coefficient, which we have not changed anywhere in this model, and the tax rate. And it shows by example that if you cut the tax rate, the multiplier rises. And if you go back and look at the math of it, that would be true. And in fact, we have tax collections of 523.64, so we have lost taxes, however, despite the fact that disposable income is up, despite the fact that consumption is way up, the cost of the tax cut is still pretty sizable, and taxes collected are 523 as opposed to originally 560, and so this causes the budget deficit to soar from 40 to right here to 76.36. So it certainly does not pay for itself. There's a rather sizable increase in decrease, I should say, in the tax rate. It's a 10% decrease in the tax rate, but it really has a strong effect upon budget deficits. So this perhaps runs contrary to the argument that tax cuts can pay for themselves, which is not an argument that should ever be believed, or rarely should be believed. So that's a good application of this model. It shows a lot about the multiplier and the sort of effects of autonomous spending, but this isn't good enough for us. And there's a couple of reasons why it's not. It's just too simple. Now, I remind you, this is the primary textbook model that was used for 4 decades, really, in introductory macroeconomics. It's one of the reasons why I moved away from using textbooks, because it wasn't supplemented to add something more complicated. It was the model. The multiplier was in the model and explained as such. And we're going to see in the next version of the model that the multiplier really gets watered down. But the model does not really let us evaluate simultaneous policies or complex feedback effects, which are the advantages of a good model. Now, it's harder for me to explain that here than it will be to show it to you in MacroSim 2, so I'll come back to this complaint, and we'll look at it in MacroSim 2, and you'll understand it then. A real short side of this model, a deficiency, is investment is autonomous and exogenous in this model. It should be endogenous. It should be determined within. It can't be added to the outside. And that raises the obvious point that there's no finance market, there's no interest rate in this model, and that's going to obviously influence investment in a real economy. And that allows us to conclude that we need to bring the loanable funds model, which we've already seen in this class. You can recognize it right here. We need to bring that into this model. So slide set 3 is going to do exactly that. So that concludes this.